We are on page 70 without the ohms wheel. A factory motor requires 4,000 watts and runs on a 440 volt supply. How much current does it draw? So we can use the pi formula to find this missing piece. And we are trying to find I. So anything that's not I goes to this side. And so I is going to be 4,000, divided by 440. And I don't think this one is going to be very pretty. So let me use my calculator. 4,000 divide 440. And that is approximately 9.09 amps. A battery pack supplies 48 volts to an electric bike with a resistance of 6 ohms. Find the power output. So I'm first of all going to do the EIR formula to find I, and then I'll turn around and use that one to finish the problem. So EIR, and we want to find I. So not I. That means R moves. So I is equal to 48 over 6. And I don't need a calculator for that. That's going to go 8 times. So I is 8 amps. And now that I've found that value, I can use the pi formula to finish this problem. So P equals IE. I am looking for power output, so we're looking for P, power. And the not P's are on the other side already lined up. So I is 8, E is 48, and I believe it's 394, but let's see, 48 times 8, how about 384? 384 watts. And that is your final answer. Number 51. If power is 2,400 watts and resistance is 6 ohms, oh boy, what is current? So we're looking for I. And this one's a little bit more of a challenge. This one is one where I would appreciate my ohms wheel. This one's going to involve some algebra. If you are not comfortable with algebra, you might want to skip these last two. But for those of you who are, or I said the last two, it looks like, yes, number 52 is very similar to 51, so I suspect they're going to work the same way. So you can skip these two and use the ohms wheel if you would like to do that. But first of all, let's try the pi formula. I do know power, but I do not know current or voltage, and therein lies the problem. I need one of those to solve this. So let's try EIR. And we don't know E, we don't know I, but we do know R. So the problem is that in both of these formulas, I have two variables still remaining, and I cannot solve it without a third variable, at least not the way we've been doing it. So what I want to do here, I know that ultimately we're looking for I, but I want to get both equations in terms of E, in terms of voltage, so that I can substitute into a system of equations. So I want to solve for E. Now, this one is already solved for E. You have E on one side and I6 on the other side. That one is not a problem. This one, I need to move that I out of there in order to isolate the variable E. So what I'm left with, both equations are solved for E, which is what I wanted. One of them is I6 and one of them is 2400 over I. And this is where the algebra comes in. We're going to set those two yellow parts equal. So 2400 over I is equal to I times 6. So I have just brought this yellow portion and this yellow portion down and set them equal. And I can do that because both of them are E. Both of them are solved in terms of E. Now that I've done this, we have to do some math. And this is actually going to be a type of equation that we'll have to solve with trig or something very similar. So you're getting sort of an introduction to trig, but you will understand trig better, I think. This is sort of a random thing. Use the Ohm's wheel if you have it, and you won't have to worry about this. But here, I'm going to multiply both sides by I. I'm not going to put parentheses there because I don't want to make that look like distribution. So on this side, we're canceling this denominator. And then here's what I'm left with. 2400 equals I times I is I squared times 6. So I want to isolate I. I'm going to divide both sides by 6 and cancel. So I'm left with I squared equals 6 into 24. That goes 4 times with 2 zeros. And then when you take the square root of both sides, you have your current. You have 20 amps. And that's what we were looking for from the beginning, the current. Same formula or process will work down here, except this time we're looking for voltage. So we have power of 2400 watts, resistance of 6 ohms, and we want to know voltage. So if we set up the pi formula using what we have 2400 equals IE. We don't know either of those at this moment. If you hear a funny noise, it's the cat's litter box making that awful sound, but it's a great thing. Okay, on this one, we don't know E, we don't know I, but we do know R. And I'm looking for voltage, so this time I want to get everything in terms of current. I want to get these two to be equal, and then I can solve for voltage. That'll be my last step. So current, we want to solve both equations for that. So here I'm going to divide both sides by 6. And here I'm going to divide both sides by E. Now don't panic on me. We're going to be okay here. We have both equations in terms of I. So here's what we will set equal. We have 24 over E on one side, 2400 over E on one side, and on the other side we have E over 6. And those are equal because those two I's are equal. If these are equal, these are equal. And that gives me this proportion. So to solve this one, I'm going to multiply this way to get E squared. And then on the other side, I'm going to multiply this way to get 2400 times 6. And that's 14,400. And I'm going to take the square root of both sides to get E. And you got it. Voltage is 120 volts. The ohms wheel will be very helpful to you on 51 and 52. But if you like algebra and you understand how to manipulate these formulas, you can solve it that way. It's a little bit more intense than what we've been doing so far. So I strongly recommend on these two to use the wheel if you have the wheel available. And you won't have to worry about all this algebra.